Tonight I want to talk about capturing speed of user experience and how can we do that, right? And in particular, how can we do that using UserTiming API? A couple words about myself, which you probably know most of it already. I care about speed of user experience. That's probably my defining characteristic, although my LinkedIn profile says web addict, so maybe I should update it, right? Speed addict or something like that. I don't know. I organize this meetup, obviously, and I work on the web platform team here at Meetup, where we are doing some performance work, including user timing work that I'm going to talk about tonight. So, before we go into describing how to do user timing and things, I want to quickly talk about why it matters. Why do we measure speed at all, right? Not why speed matters. Hopefully that is more or less clear to you, but why we measure speed. And operations folks do that to understand degradation. Developers do that to analyze their application for deficiencies, but also to verify that what they did actually improves speed. Very important topic, don't forget that part. Business folks and technology managers actually need to measure in order to be able to prioritize improvements, right? Because you can have something very expensive but not providing a lot of value, right? And more importantly, when you do have something expensive and it does provide a lot of value, you actually need to prove it, and you need money to build the project, and it's a big challenge to get the budget for that. I don't know if many of you had that challenge, but trust me, it is a big challenge. And to have those conversations about money, you need good numbers. And this is an example, and that's the WPOstats.com site that I mentioned in the intro. They publish these kind of stories that connect performance improvements to business KPIs, right? And some of these numbers are just mind-blowing, frankly. You know, that's kind of probably why I started doing this and I'm still passionate about it for the last 10 years. Because some of these improvements just crazy. And I mean, some of those top ones, maybe not the latest, there are actually even better numbers from latest Pinterest work on progressive web apps, for example. But also things like stickiness after experiment. Mind-blowing, long-term effect of performance, right? So in order to create these business cases in-house, external data works great, but you do need your own data as well. And that's why you need to measure, because sometimes it's very hard to believe somebody else's data. So there are two primary methods of measuring or collecting metrics, I should say, and they are synthetic monitoring, right, where you have a computer running somewhere that pretends to be a user, right? There is like a browser. Well, by now, all the synthetic monitors use more or less real browsers, right? And they point it at your website and measure how fast it loads. And the great thing about it is that they collect a lot of data for you to analyze, because it's a fake user, it's your computer instrumented with all the tools. It can actually capture a lot of information, right? Like, for example, a video of screenshots, right? It can collect screenshots. Imagine doing that for real users, right? That's probably not realistic, right? The downsides of this method, though, is that you only have one metric, one value for the metric. Like when you test it, like you emulated one user, right? You can test from many locations and multiple times, like, for example, Catchpoint I mentioned, or WebPageTest.org, our main tool we use at our Meet for Speed sessions. But it's not really a full view of real users, right? When I said it's a fake user, you always need to remember it's a fake user. It's great for analysis, but it's not representing real user experience. And that's where real user measurement solutions come in, and that's why they're so popular these days, or at least that's why they're so expensive, because it's actually a big effort too, to collect data from all the users, right? And it's usually done by injecting some JavaScript in the page and actually measuring what happened when user accesses your site. Not simulating it, but actually measuring. And you do get a lot of data from all the users, but not as much as in synthetic for each individual one, right? You can collect some metrics, collect them from all the users, and more importantly, draw things like this, the histograms of what is the distribution of speed among your users. Because there is no one number that represents speed. It's always a distribution, right? For some users it's faster, for some users it's slower. And what you can do in the ROM as well, you can actually measure their KPIs on those users, wherever they click the buy button or watch the video or whatever is important to your business, right? And you can connect the two, because for the very same user, you know the speed data and you know their KPI data, right? And that's probably the most important feature of real user measurement, because then you can see right away how KPIs differ based on speed. Right. We're not going to go talk too much about that tonight, but it's also a very important topic. We actually had a few sessions here before about it. When we talk about speed and measurement, there is one thing that is problematic to this day. A lot of times when I talk to people who try to measure speed, oftentimes they talk about measuring what technology does. Page load is a famous page load event. Well, time to first byte and things like that, right? Or like whatever you can measure, right? They're measuring that, but we forget that we need to measure what user experiences. Because in the end, computers don't click buy buttons, right? People click buy buttons. They try to buy, and if you're not in e-commerce, I mean, the buy button might not be the main thing you talk about, but you built a website for a purpose. Users need to do something there, and that's what we need to measure. And forever it will be hard, because it's very hard for a computer to measure a person, and hopefully that never gets to 100% precision, right? You know, but we need to measure that so we can optimize experience for the user. We can make that connected to real KPIs, and the closer you are to measuring the person's desire to buy, a person's behavior, the closer you are to correlating that with business metrics in a more precise manner. And because of that, we shouldn't measure what's easy to measure, those technical things that we feel that we have control of. We need to measure what matters to the user. So let's quickly talk about the metrics that are used today, because it's a pretty long story of how we got to this metric, so I'm not gonna go way deep, right? But we started with metrics that were closer to our hardware. Like we monitored our servers, right? We monitored how they behaved. We monitored like very low-level networking, like DNS, TLS, things like that. And time to first byte was our primary metric, because that's the code that we wrote, right? Our server database queries, things like that. And then at some point, about 10-something years ago, maybe a little earlier, we realized that that's actually not what users experience. Yes, surely servers need to do their work in order for page to show, but pages kind of show at the, like, experience shows up in a very different, unrelated to the server work way, right? And that's where metrics like page load, document complete started to appear, where browsers started to report those metrics, and we started to collect them to know, hey, what is that is browser doing and not our server, right? But it was still not enough, because we don't care about page load, especially when we started to build complicated applications that like can behave very differently in regards to what browser thinks the page is. Single page applications, for example, right? The measurement of what browser thinks is the load time stopped being accurate. Like so inaccurate that it can be 100% off in either direction, and you will never know that it's true. You can still build the applications that match that very well, but we are not building applications so we can measure them. It's that way around, right? So that's where newer metrics started to emerge, and things like first paint, and first contentful paint, above the fold time and speed index, those metrics are closer to measuring what user experiences. So let's talk about them quickly. Time to first paint, right? Very good metric. You want it to be as low as possible. There's one downside. It tells you when this happens, right? Not very relatable to the user. Yes, lack of content is kind of important, right? Like you don't want it not to be shown, right? But it's not a very great metric in this sense that it's not representing experience, it's representing lack of experience. Still, very accurate. One of the best metrics that is as precisely measured by the browser as it does, which it doesn't 100% precisely measure it, but anyway, good metric. Above the fold time is a little harder to measure because, like, in synthetic world, it's easy when you collect the actual screenshots. In the browser world, in the real user measurement world, it's harder. But it represents when everything that can be visible in the first screen is visible. Not bad, right? A good metric. Like, clearly it shows you when user sees the whole page rendered. Kind of, you would think that's the experience, right? That's what we are trying to deliver to the user. Unfortunately, it's not completely correct, right? Because users don't need every pixel on your page, right? They need some things more than others, right? And can interact and have a great experience somewhere in between these two moments. And that's what Speed Index tries to kind of solve. And it's a good measure, I would say, of experience, because what it shows you, it's basically this progression chart, like from 0, which is like which is the first paint, right? First paint happened here, to last paint happened there, right? How does user progress from one point to another? In some websites, it's like, okay, first pixel, it's like 1 pixel in the top corner, and then in 20 seconds you have the whole page just to show up. Right? That's probably negative, and that's where Speed Index will be higher, because technically it measures like the area above this chart, right? So the slower your progression happens, the higher the number will be, right? For some websites, it paints most of it quickly and then paints the rest of the pixels a little later. So the number will be lower, even if first paint time and above the fold time are the same. So it's a good measure, kind of good automatable measure when you can capture it, which again is easier to do in synthetic world. There are some attempts to do that in RUM, but they're not great. There is one problem with this metric though. It took me like 10 minutes to wave my hands and explain what that means. And this number, what is it? Is it seconds, is it kilograms, or what is it? I don't know what that is, right? So it's a relatively hard metric to relate for people who are not into this field of measuring speed. You know, at the same time, it is more or less what we try to measure. Because these metrics are a good start, but not enough, we needed to do better. And a couple companies kind of pioneer that. And one of them is Twitter, when they introduced a metric called time to first tweet. To their business, the most important speed metric is when the first tweet, like this area, shows up. And they could kind of concentrate on that, and they started measuring it and improved their applications a lot. If you remember, Twitter went from like server-side rendered to client rendered, then to server-side rendered again, and those kind of work were powered by these kind of metrics, where they tried to figure out what is important in concentrating on their primary user experience. That's what mattered, right? It doesn't matter to them, I guess, when that logo shows up as much, but this was important to them. And Pinterest is another company. They're doing a great job, and they started later, but they're doing a great job now in showing how they sharing their knowledge, but also on actually improving the performance. And they introduced this thing called pinner wait time, right? It's a little better than the time to first tweet, because time to first tweet works only on the Twitter feed page, right? Well, I guess for Twitter, that page is like 99% of their business, right? But it's not always the case. And Pinterest did kind of introduce this a little bit more generic name, where on each page it will mean something else, something different, right? But essentially, time between action of the user and when content that needs to show up showed up. And by the way, those are articles where they talk about that. Both companies talk about that, so I recommend reading them as well. And in order to measure those things that are specific to your application, not what browser can measure automatically, right? Or a vendor can just plug into your website and just measure user experience, they cannot do that, right? But in order to do that on your application, you actually need to tell your instrumentation when things happen. And that's where UserTiming API comes in. The idea, the user here, by the way, is kind of ambiguous. It's not clear whether it's end user or developer as a user. I think the browser team actually meant developer, meaning that developers fire the marks and stuff, which we'll talk about in a second. Anyway, this API is not for browser to provide you data, but for you to record data about your user's experience. And this is the slide about this API, and I think after this slide we are done, because that's all the API there is. Right? It literally is a call to mark some event on a page, give it a name, some string, and mark it. And another one is to measure the distance between two events. And that's what marks and measures are, right? And there is nothing else in this API. That's all there is. Very simple. I think we're done. Thank you. I'm just kidding, obviously, right? Oh, it's worth saying that it has a very wide support. 91% is actually a very high number. And there is actually a polyfill by Nick Jansma that it's just a piece of JavaScript that you can run before you execute your code, and it makes it 100% the browser. The idea is that in your code, when things happen, you can just say, hey, thing happened. And it will record the time with a high precision timer. And you can retrieve them from a performance timeline. By the way, it's a different API, not UserTiming API, for reading that data. But it will create things on that timeline, basically both marks and measures, and you can read them either by type, like you can get marks or measures with individual calls, or individually by name. This API is actually used to access all kinds of performance data, not only UserTiming data. So it's a little more generic. So let me show it to you. So let's say we have a page like my home page, and we open Chrome Developer Tools. Essentially, and go to console. Essentially, what you can do is you can just say performance. Oh yeah, actually, before UserTiming, let me show you the traditional metric, how you can get what browser collects without you doing anything, and that's performance.navigation. I'm sorry, the other way around. Performance.timing, and that's the object that Navigation Timing API collects. And this is the data that automatically collected. You don't need to do anything about it, right? Let me increase the font a tiny bit. Yep. So you can see there is like DNS lookup time. There is a, what is it? DOM content loaded event, load event. What else? Response end, that's for the backend time, kind of the closest to time to first byte that you get here. You know, things like that. And that is collected automatically, right? And you can read it in your JavaScript. And by the way, those are timestamps, right? And there is an important one called navigation start, which is the time when the user asked to navigate from one page to another, right? So essentially, that's your zero. You basically subtract this number from any other number, and that's how long things took, right? So that's Navigation Timing API, right? Right away available. But again, as we discussed before, those are metrics that are not really representative of full user experience. So back to performance, to UserTiming API. So same object, performance. In your code, you can just say performance.mark. Sergey stopped talking, right? That's it. It marked the time when I stopped talking, and I started again, sorry. And then you can say, start talking again, stop talking again, right? Another mark, another moment in time, right? And you can go and say performance.get entries by type mark. Right? And there are 6 marks. Some of them we just recorded, these 2. And some of them were actually recorded on my page, which we can ignore for now. But essentially, that collected these 2 timers, right? And again, it's time from navigation start. So these timers actually already subtract navigation start timer, so you don't need to do that. So these are actually time since then. Obviously, I started typing in a console way after page loaded, right? So it's like 129,000 milliseconds, right? 129 seconds. So this is not really the numbers, the real numbers. Like you can see, these are a little more accurate, 200 milliseconds, 200 milliseconds, stuff like that, right? Now what you can do also is you can say performance.measure, and then you can say, let's say, time between talks, and then you say, you just provide 2 marks, provide 2 marks again, right? Oh. And it measured the distance between those 2 events and recorded that as well. And now if we go and read measures, you will see that there was 1 measure and the duration between the 2 was this much, right? And that's all there is to this API, right? Essentially, you record the events, you measure the distance if you need to, and that's it. And you can report and track it. I do want to show you the main method that lets you collect all the timers from the timeline, and there are quite a few of them. You know, so there are different APIs, and you can see these like 16 and 8 through 18 are actually like performance marks, right? But there are a whole bunch of others, like navigation timing actually collects another entry here, and there are like resource timing APIs. We are not talking about all of those APIs tonight because it will take forever, but a lot of interesting, useful information, and in the future, when browsers learn how to measure other things, they will start collecting them here as well. By the way, there is like this first paint event and things like that, right? So, central source of getting the performance metrics. So there are quite a lot of benefits in here, right? You are measuring your own product, right? That's the most important part. You not tracking what's standard by somebody's definition, right? Some of them are good, but again, first paint only tells you when nothing showed up. Right? So it's not very useful. So good to have that. It is instrumenting in your code base, right? Not anywhere else, right? Like you write your code close to your instrumentation code close to your own code, and not some other developer at Google who writes the code inside Chrome or whatever, Firefox and all. And the most important benefit, actually, is that it can be collected by both synthetic tools, so you can use analysis tools and see very deep into the data, as well as RAM, where you can collect it from every single user because it is JavaScript running for every user. And I think that's one of the fundamental properties of this API, which makes it much better than other tools, where you can both synthetically validate how things happen and still collect it from all the users. How reliable is first contentful paint? Greg asked me the same question earlier. Yeah, first contentful paint, just for those, I didn't go deeper into what that metric is. Essentially, it's Google's attempt to implement a better first paint metric, right? Essentially, it means that they measure when the first paint of the element within the DOM of the document object model of the page painted, right? It probably is reliable to do exactly that. Is it better? It's probably a little better than first paint, but again, still, I mean, in most of the time, it will be the same as first paint, but sometimes it's not. Like sometimes first paint is a little off. I actually don't know enough about precision of first paint to tell you how maybe there were other deficiencies in that, you know, and especially browser support. Well, I guess first contentful paint has the same problem, right? But again, it measures your technical aspects of how browser painted, right? First time. A little bit of background color might not be enough for your user to experience anything, and that's where user timing is best. But there are other cons comparing to the pros, right? In particular, it's not measuring when browser actually paints. It measures when JavaScript executed. Because it is JavaScript API, it can only be measuring when you execute it. And that's kind of problematic, right? We wanted to measure user experience, and we are back to measuring JavaScript execution, right? Another downside is also, it measures individual events on the page. Things that when you executed JavaScript, rather than a little bit more holistically, experience of the user, right? So it's very hard to convert that to something that you can track as an organization overall. No one will track like mark for when title of the page showed up or when image downloaded. It's not a good metric to track as an organization. And one thing that we probably cannot do much about, it actually requires you to write that code, right? You actually need to put the code in to do the measurement, to execute the events. It's not a huge amount of work, but for the big site, it might be quite an effort. I want to address a few, if we cannot address the third one, I will try to address the first two, and that's kind of the work that I've been doing for a while. And I actually didn't do too much of it. There was this guy, Steve Souders, maybe some of you know him, and for those of you who don't, he is the kind of the inventor of modern web performance field. He put a lot of effort into understanding how to track user experience using user timing. And so, for example, when you need to know when text that doesn't use custom font loads, you just include this script tag right after it in the DOM, in your HTML. So when text is injected into the DOM, right after that, the JavaScript will fire, and it is as close as you can get to knowing when text showed up, if it didn't use custom font. And for the images, it's a little more complicated because, in fact, Steve actually looked at like 5 or 6 different methods of doing the measurement and narrowed it down to just 2 marks. One is the same as the text. To know when image is injected into the DOM, you just put the script tag under the image tag. But then you also need to put an onload event handler to know when the image downloaded as well, right? Because it's not enough to inject it into the DOM, you also need to see it downloaded. Why do you need both? Why not to just use unload event? You don't know which one happens first. Because browser uses a speculative parser. Before it actually creates a DOM, it actually parses your HTML very quickly as it arrives into the browser and kicks off download of the resources. At the same time, once it parses the JavaScript, HTML, it will execute this JavaScript right after the image. But if pre-parser started downloading the resource, if it comes from the network, it will take a while. But if it comes from the cache, yeah, that was the look-ahead parser, yes. But if it comes from the cache, it will actually be downloaded before the parsing of DOM actually happens. So you don't know which one will fire first. So you need the latest of the two, right? Again, awesome article by Steve. I think he wrote a couple of them, but this one summarizes quite a few techniques. I'm not going to go through each one of them, but he talks about how to measure fonts, how to measure whatever CSS has loaded, right? It's not rocket science, but he actually put a lot of effort into actually statistically analyzing the data, looking at whatever browser actually does what we expect to measure. And it sounds very simple, right? Just go and just include things in HTML, but there is a lot of research. I warn you not to start making similar assumptions just out of the blue. Please make sure you understand why this simplicity is there, right? So read Steve's article and all of that, right? In reality, text and images are probably what you will do the most. You can measure fonts. I didn't include a slide, but there are a few font loading libraries that can help you measure fonts, and we did that here at Meetup, and it was useful, actually. So essentially, what Greg is referring to is that navigation timing API that provides us with navigation start measurement, for example, only works when you go from one page to another. When it's a single page application within the same page view, you have changes. Navigation start doesn't work, right? So one thing that you need to do is also track that navigation start in there. There is another aspect of it is that in single-page applications, you don't update the whole page. That's the whole point of the application. And that makes it somewhat harder to track that, right? When you come from another page to your product details page, for example, all of these marks will fire, but when you go and transition within the same single-page application to the very same page from some other homepage of your website, it will not necessarily refire all the marks, right? So you need to have some smart handling of that, right? And makes it much harder to do that. It is doable, though. It doesn't break down completely, right, Greg? You know, it's doable. And I'll mention how a little later, not necessarily full solution, but our attempt at that. These techniques, essentially, that Steve basically single-handedly wrote probably all of them, they allow you to understand when as close to what browser does by measuring JavaScript. You fire something in JavaScript and it helps you understand what did browser do. Whatever it showed the image, showed the text, things like that. Lets you solve this problem that we are measuring actual browser. There is another technique that actually was discovered by Nolan Lawson. The thing is that no matter how good we are at tracking and firing our JavaScript marks, they are tracking only this side of the world. But browser, after JavaScript, any JavaScript change happens, needs to calculate the styles, lay out the page, and then render. And only at this point in time, afterwards, is something visible to the user. And no matter how accurate, how well you inject your JavaScripts into the pages, right, into the DOM, or fire them from your script, let's say you updated in your single-page application, updated part of the page. You fired your JavaScript to say, hey, I updated it. It still takes time for it to be painted. And that's what Nolan solved, right? He looked into a few methods and he's like, okay, but browser already has some method of knowing whatever it's ready to paint, right? And that's a request animation frame. I don't know how many of you worked with animations in the browser, but there is a technique, instead of using like set timeout, I'm sorry, right, to just paint every 100 milliseconds, right? There is a technique to be much more precise in painting your animation called request animation frame. And that actually moves you much closer to when browser actually painted or supposed to paint, right? It basically says, hey, I'm about to paint, fire something up. And there are a few, like his article talks about why there is also another set timeout within it. Right? So you request animation frame, then you set timeout with 0. There's no, usually there is the second argument with a number, and by default it's 0, right? So it basically releases the JavaScript thread, and only on the next execution it actually fires the mark, right? So it essentially says, oh, wait for the paint, then let browser do whatever it does, and then fire the mark, right? I might not be explaining it in the best possible way, so read that article, but the whole idea of this technique, and I call it waiting for the next paint, right, is to not to measure JavaScript execution, but measure when browser actually does the actual painting on the screen. It's relatively recent, like a couple months ago, well, September 25th, like here's the URL, when he discovered it and wrote about it, because for a long time, people using user timing were having like very weird measurements, and some folks, for example, Wikipedia team didn't use this technique because it was way off, right? Like it was firing JavaScript events in the wrong times, right? And for their precision, Wikipedia is pretty fast website, it wasn't good enough. If your website loads 20 seconds, takes 20 seconds to load, your unload will be way different than precision of user timing anyway. But if the website loads within 500 milliseconds, like this imprecision matters. Again, I want everybody to remember that we're trying to measure user experience. So even if we are very precise in measuring how fast things painted on the screen, it's not measuring how fast users saw them. Right? So don't approach it with the desire to be 100% precise, right? And the moment it is off, giving up, right? That it just doesn't work. So as close we get to measuring what users saw, the better, right? And this technique is probably the best technique, basically. Execute the code within your application as it does things and measure that. With a few tricks to be a little more precise. I don't know if I want to talk about fonts, but yeah. Fonts were kind of challenging because people kind of assume that the moment text is available, it's their own, but if you use custom fonts, it's not. It's going to be empty. Maybe some of you saw that on your pages. So to address the second problem that I talked about, which is using individual technical events in the browser is not very useful for organization, I want to talk about the project that I started called UX-Capture. And that's basically a wrapper around UserTiming API that lets us define metrics that matter, like that pin or wait time, as Pinterest called it, right? That matters across the pages. And it's very simple. Essentially, you go and you define the view and you say that you group essentially all the marks into groups, and you say primary content is considered displayed when we show the intro, when they show the story, and when on load image for the kitten, unload event fired and inline event fired for the image. And you say when all of these events happen, we can consider that the primary content showed up. Well, for destination verified phase, only title is necessary, right? So you group these things together. And then you just wrap the mark, instead of using performance.mark, you just use UX-Capture.mark call, right? The very same kind of type of call, you just fire them at the same time you would fire performance.mark. But what it will do, it will wait until the last one of the marks in this group, or zone maybe we call them, fires, and say, hey, our zone is ready, let's record the measure. Remember UserTiming API allowed you to do measures between the events, right? And basically what it will do, it will measure from navigation start and that last moment in the group and say, well, that's when the zone was painted, this phase of page load is complete, right? And essentially you will start treating those groups as your metrics, right? Let's say primary content, right? Or destination verified. Those groups that matter to you and can be applied to every page that you have, right? It does a couple other useful things like waiting for next paint, as we discussed, kind of a trick technique, right? And it also records the console timestamp to be able to debug this in Chrome Developer Tools and Firefox Performance Timeline, I think it's called. Because it's not, the performance marks are not shown in those tools by default. You can, as we looked at console, you can read them, but you cannot see them in the tools. Let me quickly show you how that works. And that's the test page for that application, hence the kitten, the cute kitten. Best thing you can do, right? So essentially, if you look at the source of this page, but there is this inclusion in the library. In real production, you want to inline that, actually, instead of separate resource. But for the test page, it's good. And then you initialize the library. And by the way, it also lets you kind of have an event for your own instrumentation. Let's say you use a tool that doesn't pick up user timing marks and measures automatically. You want to send it to your New Relic, for example. You would go and just say, hey, on measure, when measure is recorded, call my custom method. This particular custom method just does console log. Not very useful, but just an example, right? But most importantly, you then define these zones, right? And the title, intro story, all of that. So basically, if you look at the page itself, you will know, like, okay, maybe we can say that user landed on the page they wanted to if they see the title. Right? It's the minimum required thing for them to see before they click back and go back to the search engine or whatever they came from saying, oh, I never saw a thing, right? And, but for primary content, maybe we consider this image and maybe this first paragraph of text to be enough for them to start consuming the content and be calm and wait a little longer for the rest of the code to load, right? And so on and so on. So you go and define these zones inside the code, as we discussed, we have a few marks, kitten on load, kitten in line, and some text in line and things like that. And in the end, it goes and captures those, like it would with the UserTiming API. But when all of these marks fired, it will record the measures. So let me show you that. So let's reload the page just so you see how that is done. By the way, that's a neat trick. You can go and delete the body and the head so it looks empty, but it's the same URL. Because next thing you want to do, in Performance tab over here, you can just click this reload button, and it will start loading everything and recording it. If you don't, it will kind of record the previous view of this page and then next view, but erasing body and head is useful. Sorry, it's maybe too much. But essentially, it went ahead and recorded all of that, right? And if we zoom in into the beginning of this view, right? Oh man, let me zoom out a little so you can see a little more tools, right? So you can see that it went ahead and recorded individual measures, right? So this is the destination verified, took 398 milliseconds. Primary content was almost immediately displayed, but then like secondary content was displayed very quickly, but primary content took a little while to display. I actually have like a JavaScript loop to slow it down a little to emulate bad experience because this page is very fast. Yes, let me see, secondary content. Where's my secondary content? Page 2. Actually, it's very weird that it loaded very fast. I don't know why it loaded very fast. It wasn't supposed to. That's so strange. I'm sorry? No, I don't think that's really... Oh, yes, that's right. That's actually because image was considered primary content, right? And the image actually took a while to load as well, right? So even though the text showed up relatively quickly, and you can see how that happens, right? Image took a little longer to show, and we were like, okay, image is very important, it's primary content, but we actually made it slower to load. Well, in case of images, it's relatively hard to make it different, but you will find it very funny how something is very important on a page, and it's like requires a ton of JavaScript, network requests, and things like that, but all the secondary navigation and secondary content on the page loads very quickly, right? Like, makes you feel that maybe you need to change some code of yours, right, to reorder it. And that's essentially what this library is for. And you can also see that if we zoom in on this bar, this frames bar, right, you can see there's this little marks, this little orange mark, vertical bars, right? And those are those console timestamps, because unfortunately Chrome DevTools doesn't show marks in this chart, but the fact that we record the console timestamp at the same time we record the mark, that's where they are. And you can see that basically, so this one is text title, and that's when the measure was finished, right? You can see that they're related. And then we had a few other marks, and the last one of them just considered content, secondary content finished, right? So console timestamp is very useful for debugging. It's worth saying that this technique of deleting the body and then reloading is very important, because unlike marks, the performance user timing marks, console timestamp is based on when you started recording, not when navigation happened. So if you just click this red button, record, and then reload, this time between record and reload will actually be counted into this number that console timestamp records over here. So be careful with that. It threw off quite a lot of debugging. We're like, why is all of this like so shifted? And when you realize that all of them are shifted for the same amount, you're like, oh crap. It's called time origin and stuff like that. And apparently time origin in here is when you press the record button, which kind of makes sense because that's the whole point of this UI, right? Like record something, click things around and stop, and you know what else? Like all clicks are the interaction you wanted to record. Anyway, minor thing, but just keep in mind that console timestamp has one disadvantage. It's that. And so another thing I wanted to show here is how to debug whatever things fired actually when you wanted them to fire. Because in the end, we don't care when things are recorded. We care when things shown up. Remember, that was like the most important thing, right? Like measure what matters, not what you can measure, right? For that reason, in synthetic tools like Chrome Developer Tools, you can go and look at the frames as they were painted, right? You can see that kitten on the bottom, right? And you can double-click that kitten and see these timers over here, and you can navigate left and right and see how many frames were actually painted, right? And that's how you know that, like, hey, at this point, text showed up. Okay, looks like we measured close enough to that, right? It's definitely better than unload event that happened God knows when, right? And here, okay, this frame is when the kitten actually downloaded. Okay, looks like this frame is not enough for kitten to be considered downloaded, and this one is shown. And that's why this mark fired over here, right? So that's how you verify in synthetic method, right? Chrome Developer Tools is your synthetic tool that runs on your computer instead of like some cloud computer, right? That it actually fires when you want it to fire. Because if you don't verify it, and then you go and you collect the numbers using real user measurement, that's all you have to go with, right? Like, okay, I collected the number. Is that accurate? I don't know. Right? So this is a very, very important step. Keep that in mind.
To compare later, right?
So to basically make sure that the method of including the mark into your code actually corresponded to what you wanted to show up, right? And if it does correspond, then you can go and trust your RAM data more or less, right? But if it doesn't, then like, okay, I fired some number and I recorded it, who cares, right? Any questions in the demo? Anything to show? Yeah?
How much actual execution time does the inclusion of these additional script tags and so on actually add?
How to answer it best? Little time. There are a few milliseconds spent in JavaScript parsing and execution, yes.
So it's like 10 milliseconds per script block, inline script block.
Sometimes it's faster. It depends on the CPU. It depends on a whole bunch of things, right? Incorporation of measurement is always like Schrödinger's effect, right? Like whatever cat or dead or alive, you need to open the box to know, right? There is no way to measure, and basically measurability is complicated, right? But comparing to overall impact we have today, I don't think we're talking about tens of milliseconds of page load time today, right? I think we're talking about tens of thousands of milliseconds today, in reality, right? Maybe on your computer, very fast computer, with all of caches primed, it's faster, and that's why we have this problem to begin with, because developers feel it fast. But in reality, it's tens of thousands of milliseconds, sometimes hundreds. Well, hundreds is kind of extreme, but you know, basically 10 seconds, 20 seconds is not unheard of. It's probably the most common time your users, especially when they're mobile phone, are spending waiting for things, right? So 10 millisecond execution time is minimal. Obviously, including the library in line also affects network. Like, so there is a measurement cost, but it's negligible comparing to the lost optimization that you have. In fact, like, imagine you discovered that your primary kitten shows up too late, right? And you're like, we bet all of them a marketing campaign on that kitten to show up, and you didn't do that. Let's say it's a carousel that requires JavaScript and it takes 10 seconds to load, right? Nobody waited for our kitten. It was awesome and it meowed and all of that, and nobody saw it. Why, like, and they left before, right? It's very important. And by the way, it sounds very abstract, but the reality is it's exactly the problems we figure out with these techniques when we measure it, because we find things that were not obvious to us before, right? We start analyzing. Technically, you don't need to measure. You can just go and look at the waterfall, capture synthetic test, but you cannot do it for all the users anyway. So that's why you need to measure. So again, it does the next paint thing, right? That it goes and waits for next paint. And in some cases, it's a significant amount of time. if you have a very intensive layout or CSS and things like that. Or you have CPU hogged with your JavaScript, right? It's not like, oh, wait for another millisecond and then record it. Sometimes it's 200, 300, 400 milliseconds that you need to wait. And does the timestamp useful for debugging. I did the demo already. So you can find the library at my account right now. We actually work with it at Meetup, so it will probably move up from my personal account. So right now, the library only supports page views mode when it's one page view. So in your single page applications, it will not work today. We are working on implementing single page functionality, so you can track your new navigation start. Remember, no navigation at timing API anymore, so you have to actually tell the application when you started, the transition started, right? It will do all kinds of like tracking, whatever it needs to track, whatever element reloaded or not, and things like that. Once we implement it, you know. So if you're using single page applications, it's probably not ready for you, but if you have regular page views, it's very useful. And don't forget, page view is the slowest part of your views if you have a single page application. So it's probably something you want to optimize the most. Yes?
What is the limit on marks and measures you can have?
100 billion. I'm just kidding. I don't know the limit. It's, from what I understand, 10, 20, 30, 50 is probably okay. Like talking about like how much overhead there is, right? So don't go crazy on it, but I found that regular page worth of content, if you have like 4 measures, like I'm talking about, 4 metrics you want to track, 4 zones, which I urge you all to kind of not go beyond that, but not go lower than that. It's probably enough. It's probably not negligible. You don't need to worry about it too much. There is probably an overhead, like if you fire 100 million of these, then yeah, it's probably affecting your, but I hope you're not doing 100 million of anything on the page. Right? So back to these, right? These groups, what groups the elements together, right? Individual image, individual text showing up and stuff like that. But another great aspect of these groups is that they actually speak business language, right? They talk about what designers designed, what product managers wanted to happen, right? Primary content, when did it show up? When was my primary action of adding to cart available? Things like that. So another aspect of these measurements is that they are not a technical exercise anymore. They are a business exercise, which is what we want to do, right? I found that it opens conversation with business folks much better than ability to measure time to first byte or on-load event, which are some kind of numbers that we geeks love and geek over and shift improve, but business folks have a hard time to relate to, right? So it's very useful, and also if you define them differently on different pages, you can still track them across the site. When did primary content show up on this page and on this page? Well, users want it fast enough on both cases, right? And like, please optimize it, right? It's a good measurement to track, so I suggest converting these into specifically metrics and tracking across the site. And speaking of tracking, you can do it both in synthetic, as we discussed, and you can analyze it in the proof, and you can use it in RUM and correlate them to KPIs. Remember, if you track both speed and conversion or whatever other KPI you have, for each user, you can actually model improvements very well. Not only track that over time using synthetic like here, but also model, oh, if we improved for these users who are slow, if you move them to the faster bucket, how much better your conversion will be, right? That will let you predict and prioritize and budget work before you implement the improvement. Remember, one of the challenges for a lot of data-driven decisions is that in order to A/B test it, which is the best way to measure, to compare two solutions, you need to build 2 versions and A/B test it, run it in parallel, measure both and compare. With real user measurement, you already have users for whom it's slow and already have users for whom it's fast, right? And you can compare that without running experiments specific for improvement, right? So if you measure these user experience metrics and compare them to user KPIs, that is the best way to drive business decision, prioritization decisions. Works particularly well when you need to spend a lot of money and time to, let's say, implement a new CDN. Well, some CDNs are easy to implement, but or invest into font loading or maybe image processing technology, right? Those decisions are not made lightly, and you need to prove it. And last but not least, maybe concentrating on user experience and measuring it will finally help you design your experience to be fast. When you think of, when did my primary content show up? I want it sooner, right? And that other thing can lazy load, right? Someone mentioned lazy loading before, right? Or we can show public content very quickly, but then authenticated and personalized content needs to wait for authentication call, this call, that call, right? Like things that take longer. But at least you design that experience. Like well, you might not be able to see it, but I particularly like this gray background on YouTube homepage. It shows you that there will be content here, but there's zero content. They don't need to know what the content is before doing that, right? So if you design it this way, you will be building it this way. Right? So I highly encourage that. Thank you.